Hello, my name is Greg Verstraeten. I'm a product manager within OCI, and I'm focused on Oracle functions and in general cloud native services. So this session is getting started with serverless apps on Oracle Cloud Infrastructure, OCI. So this will be about we'll talk about the services that will help you build your applications, serverless application on OCI. Along with me on the chat are my colleagues Sachin and Dushko. So please put your questions in the Q&A, the Zoom Q&A, and Sachin and Dushko will address them in the Q&A via the chat. And at the end of this session, let's review the most common questions. Any questions that were not addressed, we'll address them at the end. So this is our safe harbor slide. Do not make a purchasing decision based on what I'm going to say. Our services evolve and improve constantly. OCI has a complete portfolio of tools and services to build and run your applications. We want those services to be complete, integrated with one another, and open. We invest in open source technologies as it is our fundamental basis for portability. When you deal with open source project, it's easy for you to feel not locked in, and you're able to either run the same thing on premises or with other clouds. So we contribute to Kubernetes, to Docker, to Linux, and we also lead some projects. We maintain some projects that you know. For example, Java, MySQL, smaller project that you may use every day, such as VirtualBox. And we differentiate on the quality of our service and our operational excellence. For example, we have all those services a full transparent management. All of them are compliant with the standards. We use open source projects whenever it makes sense, whenever when they exist, and we make our services secure and performant. So not all the services that I show here, that help you to adopt OCI, to start with OCI, or the tools that help you build your application, deploy them, or operate when you go to production. Not all of them are serverless, but some of them are, and I'm going to go in detail on them. So let's start with Oracle Functions. Oracle Functions is our functions as a service platform. It is, I think the serverless trend started with this service. Basically, with a function as a service platform, and it is true for OCI and all other clouds. With a function as a service platform, you run your code, and you don't have to worry about the infrastructure on which your code runs. So it is serverless because you don't have to manage the infrastructure. It doesn't mean that it's not there. It's our responsibility as a cloud provider to operate the infrastructure and run your code. The second aspect of being serverless is that you pay for the execution. Whenever your code is not executed, you don't pay anything. So we scale the infrastructure to serve the request on the execution of your code, and you pay for for the moment it's being executed. It's autonomous, as I said. You don't have to worry about the infrastructure. You don't have to patch anything. You don't have to provision anything. It is our responsibility, and it is event driven. Your code is going to be triggered when something happened, when an event happened in your cloud tenancy, or for example, if you use Oracle function to implement an API, the event here would be the HTTP requests. Oracle Functions is integrated with other cloud services within OCI, and it makes it a perfect platform to tie things all together. So how does it work? You build your code, you write your code, and you use the our CLI to package your function as a Docker image, and the CLI is going to push that image onto our registry, OCIR, our registry for Docker images. And then you're going to configure the function trigger. So as I said, it can be an event in OCI. It can also be an HTTP request. And then your code runs when it's being triggered, and you pay only for when it's ready. Whenever your function is idle, you don't have to pay anything. So the particularity of Oracle Functions is that we package the function as Docker containers, and so each function is packaged with your code and all its dependencies. So you have your Docker image that represents your function, and you can write it. You can write your code in the languages that we show here. We support Python, Java, Go, Node.js, and Ruby. What's nice about supporting to package your function as a Docker image is that if you're missing anything from our base images on which you build your function, you can always modify it. So, for example, you use a specific library that nobody uses, only you or very few people. You can customize your Docker image. You write your Docker file, add that library, your code, and use the CLI to upload that image. It's fully customizable. So, I said function integrates with OCI services. So I've got a list here on the left. The event service, notification, API gateway. We'll go more in detail on those services. Basically, those services will trigger your function. And when it's triggered, the first time it's executed ever, it's going to pull, or when you make an update, it's going to pull the image from the OCI registry and start executing. And when it's executing, the logs and the metrics are sent to the monitoring service and the logging service of OCI. And your function code can interact with other services in OCI. And we have the OCI SDK to make it easy to interact with those services. And it can interact, of course, with OCI services, but also with third-party APIs. So now the pricing. So first you have a free tier. So as part of your free tier, you have 2 million requests per month that are free, and or 400,000 gigabyte seconds per month, and that's for the resource. It's the two metrics functions are priced on. It's the number you're charged on the number of requests and the resources that your function uses. And that free tier is twice more than what AWS offers for Lambda. But this, when you use all your free tier, you pay 20 cents per million of requests, and fraction of a cent per gigabyte second of resources that you would use. That's 15% less than AWS Lambda, and that means for you can invoke more functions using more resources with OCI than AWS. So we talked about functions, and we talked about the services that can trigger your function, right? Let's talk about the event service that can trigger your function in OCI. Events allow you to respond to cloud services lifecycle events. So, for example, you have a VM or a database that is being created. That's an event. Now you terminate it. That's another event. Assigning to your tenancy would be an event. A cluster upgrade, a Kubernetes cluster upgrade is an event. An object creation on object storage is an event. And we'll use that particular event in a demo that we'll do later on. And for another example, a security alert in your tenancy, something unusual is happening. That's an event, and you can build your function based on those events to remedy if it's a problem, remedy it. If it's something normal, you can at least log it or send an email to somebody. This kind of things. And cloud events is the format of the event that is being produced follows the standard of cloud events from the Cloud Native Computing Foundation, the CNCF. So all services in OCI, or a big list of services, and the list is growing every month, can produce events. And so when and they do this, and the event service collects those events. And so then, as a user, you would configure the rules to deal with those events and what to do when they come up. And what to do is the trigger. So let's say you have you want to collect any VM that are being created. You configure a rule to trigger a function whenever there's a VM being created to see if it follows the best practice. Or you can send an alert on PagerDuty if something goes wrong, or you can just send them to streaming to analyze them as a flow. All right, we talked about functions and events. Let's talk about notifications now. Notifications allow you to send messages from OCI monitoring and OCI event service to multiple endpoints, or also from your own application or functions to those multiple endpoints. So events, monitoring, your own function applications or functions, publish alerts, and the notifications topic collects them, and so as this notification topic is distributes the event either to emails or Oracle functions, or send it to an HTTP endpoint, or PagerDuty or Slack. So emails, PagerDuty, and Slack, that would be to notify something is going on. Let's say a VM is running out of memory. The action that you want to do is to notify somebody so they can deal with the problem. So you would send an email, PagerDuty, or Slack. But then you can say, right, notifying somebody is good, but I might as well take automatic action. So for this, you would develop your function to take action. So my VM is running out of memory. I can just increase the memory for that VM until somebody comes and see what's process takes so much memory. What are the circumstances, and that can easily be done with functions. Now let's talk about API gateway. So far we talked about events that can trigger functions. We talked about notification that can trigger functions. API gateway is another way, and that's when you take you want to implement your API as a function. With the API gateway, you expose your API publicly or privately in a secure manner and in a manageable manner. It's going to handle the routing, rate limiting, the authentication to your API. It supports cross-origin resource sharing. So with API gateway is going to be the front of all your APIs, and your APIs can be so you would have your web web application, your client, and the web application or mobile application, and as part of its functionality, it has to invoke several APIs. So all the calls will go through API gateway. And the APIs in the backend, you will put your APIs that can be implemented as a function, can be an API implemented and running in a Kubernetes cluster, or on a VM, or even a database. And it can also be an API from an Oracle SaaS application, or even a third-party application. So let's now go and talk about the different use cases. We see major categories of use cases that our customer implements for functions and using the serverless services in OCI. Governance is one of those categories. Basically, you're enforcing rules that your corporate security imposes, and we'll go in several examples to more concrete example in the following slides. Implementing APIs for web, mobile, web middle tier application. That's another category. Real-time file processing, data processing is another category. We'll have a concrete example and a demo of this. Machine learning. You can, so once you train a machine learning model, you can implement it as an API for the inferences. So you will not train a model with Oracle functions or any function as a service platform, because functions are meant to be limited. The execution is meant to be limited in time. But once the model is trained, you can do the inference using Oracle functions. DevOps is another area where you would automate the action on your infrastructure automatically using functions. So first, a concrete use case about governance. You want your tenancy, your cloud tenancy, to follow certain rules. For this example, let's say you want to enforce that VMs that are created that have a public IP are authorized for it. So for this, you would use the event service. Whenever you have new resources created, like for example, compute instance, you would raise an event that would invoke trigger a function, and that function would check several things. It would check if it has a public IP. If it has a public IP, is it authorized to be created? Does it have the right security rules and everything? And if not, the function would automate the shutdown of that resource, of that VM. The second concrete use case is the ingestion of access logs in security incident management. So you have your virtual cloud network, the VCN, and the VCN, all the traffic is dumped into onto an object store bucket. Whenever those files are created on the object store bucket, the event service it emits an event, and the event service picks it up and trigger a function automatically. And the function would parse this access log files and send them to SIEM, like such as Splunk or Elasticsearch. So you can do a more analysis on this traffic. You can implement a simple ETL, a real-time ETL with serverless technologies. So, for example, you would have files that insurance claims, for example, in the form of XML or JSON file, and those files are uploaded to object storage. Object storage emits events that are picked up by the event service. And the event service triggers a function that will take those files individually and transform them and insert them in a database. We put the example of Exadata Cloud Service, can be autonomous database, or even your own database on-prem. And you can process many files using that simple ETL pipeline using functions and event service. In the context of DevOps, I mentioned it earlier, but let's say you have a virtual machine monitoring sees your monitoring service sees that the memory utilization is high, and not only just one time. For a couple of minutes, the memory is above 80%, for example. Monitoring generates alarm that creates a notification, and the notification triggers a function that resize the VM. So the function would say, okay, so that virtual machine is right now of that shape VM standard E2.1. I'm going to bump it up to E2.2. And now your VM can continue without using all the memory. So I'm not saying here that it's okay, it's all dealt with, but at least the application can continue to run with good performance until somebody goes check and see what happened, why some processes use more memory than usual. The last concrete use case that we'll talk about before the demo is extending Oracle SaaS applications with Oracle functions. So we have a service visual builder that helps you create UIs with in a low-code manner. It's all visual. And you have, for example, one of the SaaS application, Oracle Sales Cloud, and a database, autonomous transaction processing, or data warehouse on the side. And Visual Builder will invoke APIs to implement the business logic. First, the authentication. So API gateway. Your code doesn't have to do it, but API gateway will check that the request is authenticated, and then you will have an Oracle function to implement the business logic of your own application, with the front end being done with the Visual Builder. And then your business logic will interact. Your code, your function will interact with Oracle Sales Cloud. So let's say you want to have a different experience for new hires. For example, you want to have custom screens, a process of your own. Your code will interact with the API of Oracle Sales Cloud, and add thing in a database to create your own custom user experience. Okay, I have two demos that I want to show to you today. The first one is the implementation of an ETL pipeline with Oracle functions and events. So let's imagine that you have multiple databases in your company, and all the users of those databases export data in the form of CSV files, and those files are dropped onto an object storage bucket. All those files are in CSV, but you want to consolidate them into a database, autonomous data warehouse, for example, to do some data mining, to do some analysis on all this data. So you could say, okay, well, I run batch job every day to do this, or you can do it in real time. So whenever a new file is dropped onto object storage, you can process them automatically using events and function and to have that data available in your data warehouse. So whenever a new file is uploaded to the object storage bucket, this emits an event, and so the event service picks it up, and we configure a role to pick it up and trigger a function. And that function will load the data from load that CSV file, put it in your data warehouse, in the autonomous data warehouse. But then we're going to move that file. We're going to move that file into a different bucket. The reason we would do this is to be sure to be able to track which file were processed and moved onto the database. And we instead of deleting it, we move it to a different bucket so we exactly know which file were processed. So let me switch now. I'm going to go to the console. I've got to log in again. Okay. All right. First, let's go to object storage. So here I've got different bucket, and I'm not in the right region. I've got to be in Phoenix. That's where I set up my demo. I've got my input bucket, and so that's where I configured all the CSV file to be uploaded. So I'm going to select to put some of those files right now. I'm going to put three of them at a time. And so by putting multiple files in parallel, each one of the file will trigger will be one event. And so one invocation of the function will be done for each one of the files. So we'll have 3 concurrent functions being executed at the time. All right, my files are uploaded. So now let's go have a look at the event service. So I've created roles, load CSV into ADW here. So that's the service with my roles. And so as part of the role, I've got to match some events. So here in my case, it's object create. The event type is object create, and it has to be in my compartment. So a compartment in OCI is like a project. It's a division of your tenancy. So I've got a compartment of my own, and I want to match the object creation in the bucket input bucket. And so once I've got some matches, the action is the invocation of a function, and the function is part of an application, great, app1, and that's my function. So let's go click. I'm clicking on it to have a look at what it is. This is my function that I deployed using the CLI. So it is on OCIR, which is our Docker image registry. With this version, I have 256 megabytes to run this function, and I can, if I need more memory, of course I can increase it. I've got the default timeout of 30 seconds, but if needed, I can increase that timeout. So that was function. Let's go have a look at the database now. So I've got my autonomous data warehouse created. And so what's nice with autonomous database is that you have tools. It's not only just the database that is provisioned for you and managed. It's you have tools to interact with your database, to make your experience, to make the management of your database easy. So I'm going to open a SQL Developer, the web version. And so with the function I inserted the data in as with the REST API. So I'm treating the database as a document database. It doesn't mean that I can take it has to be JSON document only, but to make it easy, I just put the data as it is as JSON document in the database, and then once it's in the database, I can take it, transform it in table in a star schema for easier analysis. So I'm going to what I'm typing here is the SODA, which stands for Simple Oracle Database Access, and it's to query, manipulate documents in the database. So my collection is regions numbers minus f. So what I'm doing here is I take all the data, all the JSON document from that collection JSON regions number. And so I can see that I have my data that I put on object storage automatically inserted in this database. So now I can have I can take that data and, as I said, put it in regular tables for analysis. But it's there. Once it's in a database, it's easy to manipulate. And we can go back to the input bucket. The files are not there, but they are moved to the processed bucket, because I want to make sure, okay, my files are processed, they're here, nothing was left behind. So let me show you what the code is like. So first the CSV files, they're in that form, right? The idea is we have multiple regions in the world, and some business numbers. All of this is inserted in a database. Now for the code, it looks like this. So this function was made with Python. And the entry point of the function is the handler Python function. So first I authenticate using a resource principle. So what it means is that the function has its own authenticity, and so I can interact with other OCI services. I mean, IAM identity management let me interact with other services because that function is authorized to do so. Then I retrieve some of the parameters from the configuration of the function. For example, the database I've got to connect to. And I'm going to, as a payload for the function, I get the event JSON document. And here you have the benefit of being of having a standard of cloud events. I don't have to reinvent everything. I don't have to figure out how the message is being passed on to me, what I should expect. It's all standard. I could take that function, run it in a different cloud that supports cloud events standard, and it would be the same thing for me. Once I retrieve all this, I load the data into the database, and then I move the objects. Okay. Then I want to show you. So that the demo that we just show is the implementation of an ETL. And as we talked about earlier, you can process many files this way and automatically insert them in a database or transform them. Do whatever you have to do with those files, but in an automated fashion. What I want to demo now is the implementation of an API, and for the example, it's going to be an image processing API. So I've got to go. Slide. So I've got an application that runs in my browser, and I'm going to use the browser API to take a picture. That picture is uploaded to. We're going to invoke a function that take that image and upload it onto a object storage in a bucket. Once it's in that bucket, an event will be emitted, and I'm going to trigger. So the event will trigger a function that will take that image from the bucket and perform some simple face recognition using OpenCV. And we're going to draw on that image, modify that image based on the data from the face recognition. You'll see that we're going to add a hat, and I'll leave it as a surprise. It matched the current situation we're in. So basically, the image will be transformed and stored on a different bucket, on the output bucket, and so the application will use the API to get that image and display it on your browser. Switching windows. Not that one. Okay, I prepared it. No problem. Here, I'm going to allow my webcam. Hello, it's me. Click on the button, smile. Good enough. And so now the image is being processed. So it goes through the pipeline that we just discussed: API gateway, object storage, transformation of the image, and finally we get the modified image on this browser. So yeah, the transformation was we did a face recognition, we added the hat and a mask because this is what we have to do these days. All right. So 4 millicents, and the breakdown of the cost is like this, where you have the object storage cost here, then the API gateway cost, and the rest for functions. But again, 4 millicents per run. All right, and so quickly, that's an example of a piece of the code to implement that the function that we just saw. The handler is the method that is invoked, the entry point of your function. So in Java, an object is created whenever the function is being executed, and an handle request is the method of that object. Whatever you print as part of the function goes in the OCI login, but you can use print, or you can use any library, logging library that you want to use. Similar to the previous code, we interact with other OCI services. Here it's object storage, and the function is authenticated using a resource principle. And IAM lets controls whether the function can interact with other services in your tenancy or other object in your tenancies. Here we're modifying the picture, and then we write it to another object storage bucket. So here are some links to go further, to learn further about serverless services in OCI. You have the webpage for core functions, event, API gateway, cloud native in general. We have quick start to quickly get up to quickly deploy something and test something. Oracle function and API gateway. I put the short links on the side. And here is our GitHub repository where we put examples. So that's for you to make it easy to start with examples. For example, the ETL demo, it's all there. You can take those examples, test them, and build upon them. Thank you very much for your time today, and let's talk about let's answer your questions. And I'm sure Sachin, you already did.